We're starting the recording. Thank you, John, for reminding me. I would have completely forgotten. As I said, my name is Jeff Passmore. I work for VIAVI, formerly JDSU. That is my contact information on the screen. Feel free to write it down, take a picture of it, your cell phones, whatever you want to do. I am support, as I said. Our salespeople have the hard job. They have to represent every product that VIAVI sells. I got a pretty easy job. I specialize in just a couple things. Those things being DSL copper testing and the Wi-Fi advisor. Those are some products that we offer. So today's session, of course, going to be on the ONX-580. The class length is scheduled for 2 hours. My background is in the telephony business. I spent most of my time in cable maintenance. In my day, I wasn't given a lot of training. And quite often when I was given training, it was more on how to do things and very little on why to do them. I can remember one class we actually took turns reading out of the test set manual. Well, hell, at the end of the class, I knew where all the buttons were, but I couldn't remember why I wanted to press the button in the first place. And again, all I'm trying to illustrate here is they're really good at showing me how to do stuff, not so good at giving me the why or the practical application behind it. So we're going to blend in some of that stuff as we go through the features on the ONX that we're going to talk about today. Now we're going to go over the hardware, just a few slides, fellas. I'm not a big PowerPoint guy, but some things are very good. It's very good for. As I said, the class will last 2 hours. I am going to be forced to probably talk the whole 2 hours. I don't like to do that, but there is quite a bit of information that I want to get over. But the main thing is that you folks get something out of it. So I can get through my checklist, and if you don't get something out of it, I still fail, right? I fail completely. So a little bit of onus is on you to speak up and say, hey, Jeff, I didn't get that. You're moving too fast, slow down, whatever. So I know how to run the tester. This training's for you. The ONX-580 platform is the newest one in the Access family of products from VIAVI, JDSU. And when you pulled it out of the bag, you probably noticed that you had your hand on something. It's a substantial unit. It's not what I call feather light, right? Now, there's a real good reason for that. This is the first in this class of instrument from VIAVI that is sealed up environmentally. Now, that doesn't sound like a very big deal, but it's a huge deal from our end. The reason being is the DSL chipsets generate a tremendous amount of heat. And if they're not cooled in some fashion, they'll just sit there and melt themselves. It's unbelievable. So what our engineers came up with is a patented design for heat sink. So a lot of that extra heft comes from that heat sink, or the way to dissipate the heat. The unit is modular, right? You got a variety of different ports on the side. A lot of times guys and gals look at that side and say, oh my God, look at all that stuff. Well, it's not as bad as it appears. The POTS port there is just for a regular old dialer. The two wiring ports are for wiring specific tests found in the menu, which we're not going to talk about today. And there's two Ethernet ports and two USB ports. Now, the good thing about these ports is nothing on this instrument is port dependent. In other words, well, it didn't work because you plugged it into Ethernet port number 2 instead of, no, we don't have any of that. They're redundant. So they're just there for extras, I guess, if you want to think of it that way. Lithium powered battery, all right, we're getting the same sort of battery life that we've gotten out of the HST. The HST sets the standard in my opinion for battery life. It's phenomenal. Another big improvement, you folks can sync either through the copper test leads or the RJ45, and that's that little rubber coated jack that sits below those ports. Pretty clear on this picture here. How do I run this thing? Well, again, this is another first for VIAVI. This is a touchscreen in the access market. Now, VIAVI is a very conservative company. There was a lot of us that were opposed to touchscreens. I was one of them. I envisioned a unit covered with IckyPick and a guy my age getting really, really mad because he couldn't get something to work because the touchscreen was covered with IckyPick. Well, I lost, as I said, and we have a touch screen. And I've got to admit, it's pretty cool. But one of the design criteria was that it still had to be fully operational, independent of the screen, the touch screen. So if you get it mucked up, you can still run it by the keys. Speaking of the keys, top set of 4 keys that run across the bottom edge of the screen. Now I have a tendency to call them F keys. They kind of make sense to me. It's like F keys on your laptop or desktop keyboard. Now they line up with little icons at the bottom of the screen, and you can either touch the icon or touch the key. The unique thing, or why they're called soft keys, is as the screens change, the icons will change. So whatever F1 did a minute ago, it might do something completely different when you're on a different screen. The arrow keys are pretty self-explanatory. They walk you around in the menu structure if you want to use the keypad. And they also move you around in certain tests, like the distance cursor on the TDR. The OK button is right there in the middle. It's just an acknowledgement button. It's just, this is what I want to do, press OK. The arrow pointing to the left is a back key, escape key, however you want to think about it. Cancel key, stop, back up. I made a mistake key. Okay? It backs you up a screen at a time. The home button there, the picture of the little house, some of the menus in or on the ONX are kind of deep. I mean, it's like going down Alice in Wonderland's rabbit hole in a couple cases. And if you get to the spot and you're thinking, how in the heck did I get here? I want out of here. Press the home button. That brings you to the top. And finally, the little key over there to the far right bottom corner, that's our system tray. Now, I'll show you, primarily that's for compensating or calibrating tests. And it's also where you can go in and set up certain options. So we'll take a look at that too in a minute. That's all the PowerPoint you're going to get out of me. So we'll switch to my ONX. Now I have a way of showing my ONX on the screen to you. I'll get that up here in just a second. There we go. Can you see my tester? Yes or no?
Yes.
Thank you, sir. So when I was a young guy, taught to shoot trouble. Now, by the way, folks, I know you're CenturyLink contractors. We've done 2 of these sessions. Both sessions, we have been told that you're doing installation and repair. So this is what the presentation is tailored after, primarily the repair side. So when I was a young guy starting at the phone company, I was given a very inexpensive analog volt-ohm-meter, and I was taught to measure a cable pair for problems in a certain series of tests. And that series of tests was to first take dial tone off the cable pair, right? And then measure for battery. See if you had cross or if you were touching another cable pair. If there was no cross battery, you checked it for shorts and grounds. And if there were no shorts and grounds, you would kick it to see how far it went. Now, those 3 tests, as simple as they are the meat and potatoes of what you guys and gals will do every day if you're shooting trouble. So we're going to include these tests. So we're going to go through them sort of quickly. But the option here, or the goal here, is to show you something that you're going to use a ton, right? We're going to introduce a technology to you. We're going to show you something that you're probably itching to see. That's the TDR. And then we're going to end with DSL. So that's kind of a quick format. So all of my voltmeter tests are underneath the multimeter icon. So if I touch that or select it, that will load all the multimeter tests into the memory of the ONX. Now that's important because when a test is resident in memory, it's going to operate really fast as you go from test to test. All right? So we're starting out in volts. You got 2 types of voltage that we worry about as phone guys. One is AC voltage and one is DC voltage. Now in this particular screen, voltage is displayed in a snapshot fashion. If you look down the bottom left-hand corner of the screen, soft key number 1 is labeled with snapshot and continuous. If you look closely, the word snapshot is, it's almost like it's brought to the fore, right? and the word continuous is kind of shoved in the background. Well, that's kind of a visual toggle switch for you. So if you were to touch that screen, and I'll do mine right now, continuous will be brought to the fore, and snapshot will be shoved in the background. All right? Now, a continuous or a snapshot voltage test is pretty impressive. I mean, we're probably going to need you to mute your phone, whoever that is that's not on mute. Please do so. Really good audio on the WebEx here. So still hear you. Got some birds chirping and some wind blowing. Okay, you'll figure it out. Thank you. There you go. Great. I did 6 measurements here. I did them relatively quickly, didn't I? Now, like all modern meters, I auto range, auto scale, so you never have to worry about a range or a scale. Heck, you hook the 3 test leads up, push the button. I even moved the test leads for you, don't I? 6 measurements there, made them really quick. On the surface, that appears very attractive. Now, my wife thinks I'm a pessimist. I think I'm a realist. Anytime I see something that looks really attractive, I automatically look for what's the matter with it, right? The what's the matter with this is it's a snapshot, meaning a picture in time. So if I walked up to my dial tone line here in my office and connected the meter to it, it would show 0 volts DC until I refreshed the snapshot. All right? Now, most of the trouble that you run into as a telephone person, a large amount of the trouble, is dynamic in nature. It comes and goes, right? So most phone people prefer to see the measurement done in a continuous fashion. So I switched to continuous. Now, if we understand one of these screens, we virtually understand the whole tester. So in a continuous mode, I am only monitoring 2 of the 3 lead combinations, right? The box gets big. You got the little hypnotic spinning wheel in the top right-hand corner. You've got the results there in a very large font. And then the other kind of cool thing you have is a minimum and maximum. Now, what that is very handy for is it allows you to take your eyes off the meter. Now, depending on what type of meter you've used previously, most require you to stare at the result, right? And if you look away and the trouble appears when you're looking away, and it's gone when you look back, you missed it, didn't you? Well, not on the ONX. It will capture that under min-max. Now, I said there's 2 types of voltages, DC and AC. In the bottom right-hand corner, you'll see a toggle for that as well. Operates the same. See how DC is brought to the fore, AC is shoved to the back. So if I press soft key number 4, it switches to AC. It does it pretty darn fast. You got to be looking close to see it. Now, I promised you practical information about each one of these tests. What can I do with an AC volts test? Well, usually when you talk about AC voltage to telephone technicians, their first thought is electrical shock, right? Now, I don't know about you. Most phone companies, CenturyLink has a superb safety procedure and recommendation. But anytime I got a good shock off the cable pair is when I had my fat, sweaty little hand on that metal clip on a hot summer day and I poked into the pair, right? That's when I got a shock. Well, aside from electrical shock, what can you do with a plain old AC voltage test? Well, if you and I were at a crossbox looking at a case of trouble or looking at a pair that we might want to use, and we saw a tip to ground reading for AC of, say, 2 volts, okay? And you notice how I moved from tip to ring, tip to ground, I just touched it. So 2 volts tip to ground, and I went down and touched ring to ground, and I see 4 volts. Now, I asked my live training classes, I'm not going to do that to you, it's a little clumsy over the phone. If I had 2 volts tip to ground and 4 volts ring to ground, would that be a good or a bad thing? It would be a bad thing. Now, the AC voltage gets on our cable pair 1 of 2 ways. The power company stuff comes in physical contact with us. That's a very short-lived, violent event, right? It's over in milliseconds. Most of the time, our stuff is vaporized. The second way it gets on there is through a process called magnetic induction. Well, the thing to remember about magnetic induction, that's through the air. The power company has no way to discriminate against the wires in our cable, meaning they'll put just as much AC on the tip wire as they do on the ring wire. There's no discrimination. Therefore, when I see a difference in voltage tip to ground, ring to ground, I automatically know there's a difference between those two wires. Well, any difference in our world between tip and ring is a bad thing. So I would say to you, I don't know what it is, but I'll tell you what, we don't want to use that pair. It's in trouble. So a crude fast measurement for the balance, overall balance of the cable pair. So let's switch from AC back to DC. Now DC is where we would go for to check if the line is crossed, right? See if your line is touching another customer's line. Now this is where the min-max stuff is kind of handy because you could hook up to your cable pair, and if the dispatch trouble was ring cross, well, you could put it on ring to ground, continuous, walk back to your truck, get your cigarettes, get your coffee, whatever, come back and not miss anything because the min-max value would catch it for you. All right? Now, I had a fellow I worked with that used to say, well, a voltmeter is a voltmeter. Not in our world. There's one very important thing I want to point out to you on a voltmeter, and that's this label right up here where it says 100 k ohm term. That's called the impedance termination of the voltmeter. Now, in our longer classes, we draw this out and we go over. It's a very, very simple thing, but I'm not going to do that because it's just in the interest of time. But under the soft key options, you'll see that pop up again underneath the word standard refresh on mine, right? The little radio button has the button checked for 100 k ohm, and right below that is 1 mega ohm termination. Now, this has always been interesting to me for a couple reasons. If I go into a garage and there's 14 guys I'm going to train, and they've already got our test sets, right? I will bet $5 to your dime, 7 will have the little button on 100 k ohm, and the other 7 will have the little button on 1 mega ohm. That's reason number one. Reason number two, this is the type of stuff that I looked at in training or on testers or in training classes where they're showing me how to do stuff. I didn't have a clue on what the heck it meant, right? Now, as a young guy, I asked around. I wasn't bashful, and didn't seem like anyone else knew either. If they did, they couldn't explain it to me. Well, it's a very simple concept. Like I said, I'm not going to draw it out. The main thing to remember is if you have your meter set to one termination and your buddy has an ONX and he has it set to a different termination, right? This is going to be right in your face up here. On the HST, it's hidden. Certain cases of trouble, your meters would be wildly different in their end results, right? Wildly different. I mean, I've seen guys do this before. 4 volts on one meter, 26 volts on the other, measuring the same cable pair. Talk about confusing. Well, it all boils down to this termination stuff. So, long story short, if you ever run into a contradiction between meters and voltage, voltage is a pretty simple operation, but if you see differences, think about this termination. All right, we'll go across the icons left to right. So we've talked about AC and DC volts. We're going to resistance. Now, resistance is where we measure for shorts and grounds, right? Now, I do a lot of new technician training, brand new techs, and a lot of them kind of lock up on this ohms, kilo ohms, mega ohms, all this stuff. The terminology is troublesome to them. I know it was to me. I came to the phone company right out of high school. I was dumber than a duck. I wasn't afraid to work, but I didn't know anything, right? I've gone through a lot of the old Bell system stuff, and I really like their approach because I think their approach back in the day was targeted exactly at guys like me who really didn't know that much. So I'm looking at continuous resistance. Obviously, I have the option for a snapshot. So I can change my leads by just touching them, as we did just a minute ago. All right. I got my minimum value, my maximum value. Ohm meters, same guy that said a voltmeter is a voltmeter used to say an ohm meter is an ohm meter. Well, that's laughable as well. The ONX has a very sophisticated ohm meter in it, but the way they operate is very, very simplistic. I mean, I tell new techs if you run a flashlight, you run an ohm meter. Because all an ohm meter is a DC battery minus the switch and the bulb in the flashlight. That is an ohm meter. Now, you folks know you need a certain value that this number needs to be above in CenturyLink, right, for DSL. Isn't that 150 mega ohms, right? Now, did they give you a value for what this number should be if you're working just on a regular old POTS line? Anybody give you a number there? The first two classes, they knew all about the 150 mega ohms, but it was dead silence when I asked about what is the number for POTS. If they didn't give you one, I will suggest one to you. That is greater than 3.5 mega ohms or 3.5 M. Greater than 3.5 M. You stick with that and you will not go wrong. Right? So you may say to yourself, well, geez, 3.5 M for a POTS line, you're reading 999 mega ohms. Hell, you're reading orders of magnitude higher than 150 mega ohms. Why are you reading so high? Well, personally, I think it's marketing. I can remember my little test set didn't read greater than 10 meg. Some of you may have a sidekick or have seen a sidekick. When the needle doesn't move, that means greater than 20 meg. Dynatel took it first to 100 meg. Dynatel again took it to 999 meg. Well, not that you folks care, but from our side of the business, you can't afford to have the meter with the smallest number. So we're all sitting at greater than 999 mega ohm. Huh? Crazy high. As a cable maintenance guy, I never took 20 mega ohm of fault off of anything and have it make a difference. So I'm kind of painting a bad picture for this number, ain't I? Well, there is a place where this number is really, really handy. And it comes in primarily if you're doing a chronic, right? You've been out on this before. And man, you're just having a tough time. Let's say you're on this lady who is a chronic, or man, and I don't mean to be sexist here, a customer that is a chronic. And you measure that. It's a DSL line. And by golly, tip to ground, you've got 160 mega ohm. Well, that passes CenturyLink standard, doesn't it? But when you go down to ring to ground, you got 999 mega ohm. See where I'm getting at? There is a huge difference between those two conductors somewhere. Right? Even though they both pass, there's a big difference. Right? Trouble does not fix itself. So that might be something to lock on and chase. Good explanation for the wide variances and resistive range here. Now, I like the continuous stuff, as I said. Tip and ring, plain old POTS case of trouble, noisy static. You drive out there, it's a house that sits back off the road. It's being fed by aerial drop wire going through the trees. Your first thought would be the same as mine. Damn, I hope it's not the aerial drop wire, right? You really have no way to check it, and you can clip on there, it looks pretty good, but you're still kind of suspect. That drop wire looks old. Well, you could click your ONX across tip and ring, lay it down on the ground, go get your layup sticks, and wiggle that drop around, right? And come back to the ONX and look at your min-max numbers. There are several times as a technician, I wanted to reach out and wiggle or move something, but I couldn't look at my meter and do it at the same time, right? Well, here you can. Now, if an ohm meter is nothing more than a battery, a logical question from you would be how much battery comes out of it. Well, in this mode right here, around 20 volts DC. Right? Now, in the bottom right-hand corner, there's a button called leakage. If you press that button, you'll get the little yellow triangle with the black lightning bolt in it. That's an indication that the 20 volts has gone to 120 volts. Now, the 120 volts is a current limited supply, meaning it cannot hurt you, nor can it hurt electronic equipment. Now, voltage is often compared to pressure. So I guess a layman's analogy would be, I'm going to apply more pressure looking for a shorter ground. All right? Now, back to that terminology stuff. It's the mega ohms this and the mega ohms that. The old Bell system term for all of this was contact faults. Now, when I do new techs, I love that terminology, contact faults, right? You don't want the tip wire to be in contact with the ring wire between point A and point B, do you? You don't want either conductor to be in contact with ground or something that's attached to ground. So all the ohm meter does is see if there's contact there, and then also judge how severe the contact is. Now, what I have new guys, some of them will do it, some of them won't. You know, they get a little stiff when I ask them. But I have them do this in class. I say, take your two index fingers and touch them together just as lightly as you possibly can. Right? It's kind of funny watching guys. They're going cross-eyed. They're looking at their two index fingers. Now, I say, you could say that your two index fingers are in contact with one another, right? But the contact is not all that firm. Well, that would be representative of a high resistance fault. Now compare that to taking your two fists, balling them up, push one fist against the other as hard as you can. Your two fists are certainly in contact with one another, aren't they? But the severity of the contact is quite a bit different than your index fingers. That would be representative of a low resistance fault, your two fists touching together. So my leakage button's going to apply a little more pressure. Can't hurt you, can't hurt electronic equipment. If you walk up behind your buddy and he's kneeling down in the wet grass and you touch him on the earlobe with this when it's on leak, he will sure as heck jump. And if he's a lot bigger than you, you might want to start running. But he will know something touched him, let's put it that way. So that's our ohm meter. Any questions so far? All righty. Next in line is the opens test. Now, the opens test reads length, right? It does that by reading cable pair capacitance, right? Now, I don't know if a lot of contractors are ex-telco guys that just kind of get a little tired of working for the company and decide to go out on their own. I've met hundreds of them over my career. But you probably have heard of these tailgate sessions, right? Well, we used to have these. In the morning, they'd give you like 15 minutes, right? And they'd go over some technical subject and then send you off to work. And everybody felt great because, they were trying to make an effort to show us or to learn us up, right? Well, I can still remember the day we had the tailgate session for opens. The guy said, well, open meters read cable pair capacitance. Cable is manufactured to a value of capacitance per unit of distance. That value is 0.083 microfarads per mile. And he said that applies to 19 gauge and 26 gauge. All right, there is where I stopped understanding, right? All the electricity stuff came very hard to me. Everything seemed backwards to me. The big wire has less resistance than the small wire. 26 gauge cable is smaller than 19 in diameter. Follow me? Then he laid this capacitance thing on me. He said, well, it's the same amount of capacitance per mile, whether it's 19 or 26. Well, that was one of those days I thought, I'm not going to say anything. It's better to be thought the fool than open your mouth and remove all doubt. So I just walked away scratching my head saying, how in the hell they do that? Well, what they failed to give me was the definition of a capacitor. The definition is two conductors separated by insulation. Doesn't that sound like a cable pair to you? Of course it does. A cable pair is a long, skinny capacitor. Right? So if the conductor sizes are going to change radically, as they do with 26 and 19, and you want to hold some number the same, the only element you have left to fool with is the thickness of the insulation. So that's what cable manufacturers do. They vary the thickness. Now, this only applies across tip and ring, and it's called mutual capacitance. So what does that mean to me, Jeff? It means that if you have a nice, clean, double-sided open, that tip ring number is going to be really, really accurate. Well, we know as repair technicians, it's very rare to have a nice, clean, double-sided open, right? Usually one side is open, and the other side's making it the whole way. In that case, let's say our tip wire is open. We've got a tip open. Let's define the capacitor. Well, one conductor is the tip wire. That's the one we want to fix, right? The other conductor is labeled as ground, isn't it? Therefore, anything between the tip conductor and ground is considered the insulation. So here's where you have to tell the open meter what is between tip and ground. Is it air core cable? Is it jelly cable, pulp? All right. Now that's found under options. Select cable. And there are your different fill type options. As I tell each class, this is not rocket science. If you're sitting there thinking, well, you know, we got air core and we got split the difference. Take a shot on one, take a shot on the other, split the difference. You got a little bit of jelly, whole bunch of air, leave it set to air. You're going to get close enough. Not rocket science. You got the heavyweight champion of the world when it comes to opens to back you up. That's the TDR, right? The only thing I don't want you to do is shoot a single-sided open in jelly-filled cable, have my machine set to air core, and then report back to your boss that my open meter's no good, right? There's a wild difference in distance between air core and jelly. All right. Certain portions of the class, I'm going to ask you to put your thinking cap on. So far, I probably might have a couple of you asleep because we're talking about some very basic things. So this is thinking cap time. When our open meter reads from conductor to ground, really what our open meter is reading is from conductor to shield that just happens to be tied to ground. Let me say that again. The open meter is really reading from conductor, the broken wire, to shield that just happens to be tied to ground. Now that probably sort of sounds like I'm trying to play tricks with words, right? I'm not. I'm going to introduce or start to introduce a very important concept to you. If you went out to your truck, got a brand new box of Cat 5 IW, brought it into wherever you're sitting right now, you know exactly how long that box of Cat 5 is. It's stamped right outside the box. So you open up the Cat 5, you get out pair 1 blue white, you attach your ONX tip and ring leads to it, all right? You're going to measure its length. You need a ground. So you look around, you got one of those little safety things that you can plug into a 3-prong outlet and use the power company ground, the multi-neutral ground, the best ground around, right? So you plug into the outlet, stick your green lead over there, you go to the ONX and you measure for tip and ring length. You'll find out that even though the ONX is designed to measure Cat 3, because that's what outside cable is, it does a pretty good job on Cat 5, right? Now that's tip and ring. Now go from tip to ground and ring to ground and see what you get. Those two numbers will be so far off, it will be laughable, even though you're tied to the best ground around. Okay? Disconnect from that third prong of the electrical outlet and connect to another spare conductor in the box of Cat 5, say pair 3, white-green. Now check your ring to ground and tip to ground numbers. You'll find out they're much, much more accurate. What many of our tests need in telco is a parallel reference, right? We just get a little lazy and say ground. Well, it's really shield that just happens to be tied to ground. A little something for you to remember. All right, since opens returns a distance, this is a test that can be quote-unquote compensated. Now, to do that, you want to go to our system tray that I mentioned earlier. Now, if you're a young guy, this little icon right up here, you swipe downwards with your finger. That will take you to the system tray. Now, I get that about 1 out of every 6 attempts. So for you older guys like me, find that key that's to the right of the little house on the keypad and press it. It will do the same darn thing and take you to the system tray. The icon number 1, compensate opens. If we select that, the meter paints you a little picture that says open all 3 leads. All that means is make sure the leads are not in contact with each other. Okay? Then press compensate or OK. You've just told the open meter you're not connected to anything. Zero out any capacitance you see. So what you're trying to do here is put 0 at the end of the test leads. Right? You see a little green check mark, you're good to go. So you hit left arrow key, you should go back to the menu. And you should be showing at least 1 feet, if not 0, or 1 foot. My unit is brand new. I've had it since they started developing the unit, and I can never get mine to go to 0. I don't know why. So, anyways, that's how to compensate the open meter. All right, any questions on opens? The other thing the open meter does, I guess two things that might be of interest to you. If I'm measuring tip to ground right now, and I take my black and green leads and I short them together, you'll see a message appear on the screen, an error message. All right, see it down there in red in the bottom? Severe line impairment. Measurement will have error. Indeed, it will. Open meters do not work if the conductor you're trying to measure has a contact fault on it. All right? They don't like that. So when you run the opens test, you're actually doing 2 things at one time. You're kind of looking for a problem with resistance, plus you're looking for length. All right. We'll go to the next icon, little M, big A. Touch him. DC current. DC current is a measurement we had to make years ago. I'm just going to touch on it briefly because portions of CenturyLink may still do this. I'm not sure. But DC current was the first of a series of measurements called a closeout test. Now, when you walk up to a dial tone phone, you know you're walking up to something that has 52 volts of DC battery across it, right? You go off hook with the phone, what do you do to the line? You short it. Well, if you short a DC battery, it's just like flicking the switch on our flashlight, right? Current starts to flow. It's the current flow that the central office sees that says, hey, this person needs dial tone. That's called central office signaling, right? Do you suppose the central office needs to see a certain amount of current flowing before it gives you dial tone? Well, the answer is yes, of course. And that's why back in the day, we had to check it. So if somebody comes up to you and says, well, do a current measurement, there it is, pretty simple. We simulate the phone, by the way, when we make this measurement. And you'll just read the amount of current on the line. Now, this gets particular when the loops are long. Long loaded loops in an area of the country where you have winter and summer. It's kind of important then. Right? But if you're not being required to do it, we're not going to waste too much time on it. So we're going to go right straight to the next test, the little teeter-totter one. That is longitudinal balance. That is the, in my opinion, single best test you can make on a cable pair, bar none. Now, I know CenturyLink has to make a big deal out of this test to you, all right? I don't know if you use it or not. I mean, I'm not asking, I'm just throwing that stuff out there. What does CenturyLink tell you that number has to be? Don't they tell you it has to be greater than 60, all right? 60 dB or higher. So 60 is good, 70 is better, 80 is freaking wonderful. You very rarely see a 90 in the field, and you're only going to see greater than 100 in extremely well-balanced pieces of test gear. Now, when my sales guy asked me to do training like this, Scenario. So John calls me up, said, Jeff, we want you to do a training class for the CenturyLink contractors. I say, okay, John, how much time do I have? He said, you got 20 minutes. I would take you to this test. We would spend the entire 20 minutes on it, and I would say to you at the end, figure the rest out. It's not that hard. Huh? That's how important I think this test is for a variety of different reasons. I am going to explain to you how this test works verbally. I would encourage you after the class, unless you've got butt sets in the room there with you, to listen to it audibly. Between those two things, you will get the concept, and the concept is extremely important. Okay. I am going to bring up a little drawing board here. I should have had that open. I apologize. The longitudinal balance test has been around for decades. VIAVI certainly didn't come up with it. The Sidekick calls it by a different name. They call it the stress test. Now, I love going in where I know there's a bunch of sidekicks in the garage, because when I get to this portion of the training class, I always say, there is no such thing as stress. Oh boy. The young guys, they start to bow right up. You know, they start to stiffen right up in their chair. The old guys, they just look at me and smile, you know. I quickly tell them, hey, I'm just kidding, man. One of the worst things in the world you can do is talk negatively about your competitors. That's a classless thing to do. So I remind people, I got friends that still work at Greenlee Tempo. I asked them once, I said, why in the hell did you call it stress? You're doing longitudinal balance. Why don't you call it what it is? Their reply back to me was, we didn't think that technicians will understand the word longitudinal. Well, we all laughed, me included, right? But I was thinking in the back of my head, damn, he's right. I don't know the definition of that. So I ran home that night and I looked it up in the dictionary. It essentially means along the length of. So balance along the length of the pair. Too many words to put on the screen. Longitudinal balance creates its own noise signal. I hope you can see that all right. This is the signal it uses. 1,000 cycle tone. Now, to you old guys like me, if I said milliwatt supply tone, you know exactly what I'm talking about, right? 1,000 cycle tone in every central office in North America. Standardized tone. Know exactly what it is. The young guys I've noticed today, even though they can run circles around me on the technology and the data layer and up the stack and all this stuff, a lot of them have not been given any voice frequency training at all. So you start talking about 1,000 cycle tones, they kind of look at you like a deer in the headlight. So not knowing who I got on the other end, I'm going to give you the fastest AC class you ever had in your life. At one time or another, I hope you've all seen a picture of one of these. Well, that's a poorly drawn sine wave. The horizontal line is the zero voltage line. So anything above that's a plus voltage, anything below it's a negative voltage. If I could mark off time and say between here and here was 1 second, I would have a 1 hertz signal. And that's just the last name of the guy that dreamt this stuff up. These guys were all egomaniacs. They named everything after themselves, right? So in the case of longitudinal balance, I have 1,000 oscillations in 1 second. Boy, that's a lot. Now, to give you a feel for that, I would assume all you guys got little toners, trace toners, right? You hook up to the cable pair and you go to the other end, you use your tone probe and find it. Well, those mostly generate 577 cycles per second. Right? Again, a lot of oscillations in a second. If I looked at that second and saw 196,000 oscillations, I would be looking at a form of xDSL, or commonly referred to as T1. If in that same second I saw 2.2 million oscillations, I would be looking at the top end of the downstream band for ADSL 2 plus. And in that same second, if I saw 8 million oscillations, I'd be looking at the downstream band of a VDSL signal. Now, I don't know about you. It's hard for me to imagine 8 million anythings in a second. Huh? So all the stuff we work on, folks, it's AC signals, it's cycles, it's tone, if you want to think about it that way. That guy's come up to me all the time. Well, we do digital stuff. The hell you do. Not on the cable pair. The cable pair is just tone. It's digital on the other end. Huh? But when it's in the middle, it's just tone. That's why I say, I don't care. Give me the case of trouble. I don't care what the service is. When it's on the cable pair, it's just tone. So back to our longitudinal balance test. It's creating the signal, therefore it knows exactly how much noise it applied. Longitudinal balance is a two-step process. Step number one, I take that noise signal and I split it perfectly in half. I apply half of it tip to ground, and I apply the other half ring to ground. And if you got a sidekick, you know if you don't hook up the ground lead, stress doesn't work, does it? Step number two, the tester takes its ear and listens across tip and ring for the noise it knows is there. If the tip wire looks just like the ring wire, the noise is self-canceled and the tester doesn't hear anything. If anything should happen to one wire that doesn't equally happen to the other, the noise is not equally self-canceled. The tester begins to hear it. Right? It doesn't get much simpler than that, does it? Now, the reason I make such a big deal out of this, fellas, is this is how all noise works on the cable pair. Now, usually when you say noise to a telephone, he's thinking about a hum. He's thinking about a loud sound in his butt set on the case trouble he's dispatched on, right? Well, it certainly applies to that type of noise, but it also applies to a type of noise that we can't hear. That is DSL noise. DSL frequencies work well beyond the range of human hearing. Right? Well beyond. Dogs can't hear DSL. Right? The other thing is then you can't hear the noise that interferes with DSL, can you? So they're both inaudible to you. The good thing, they both act the same way on the cable pair. What I mean by that is they travel in what engineers call common mode. Now there's a term, I didn't understand that for 15 years, I'll be honest with you. Finally, I got to know an engineer pretty good, and I was sitting there in meetings, and it's common mode this, and it's common mode that. I don't know what the hell they're talking about. So I asked this guy, I said, what is a common mode? He said, noise to ground. I said, what? He said, noise to ground. That's common mode. We call it common mode. Well, what he means is you walk up to the network interface device on a dial tone line, you take your butt set clip from tip to ground, it's roaring like crazy, ain't it? You go from ring to ground, it's roaring too. You go across tip and ring, and it's quiet. Where'd the noise go? Now, I've had people over the years tell me, they laugh at me, well, what do you mean, Jeff? It's the ground, man. The ground's noisy. You can't clip the ground. The ground's noisy, man. No, it's not. The ground is a conductor. It cannot create anything. It's passive. The noise is already on the cable pair. The ground just allows you to hear it. I worked for the phone company, didn't tell you what I did. Last 7-8 years I was there, I worked in the noise and transmission side. So I got to work on noise stuff. Great stuff. It's great stuff. If I can do it, anybody can do it, right? Now, they would leave you alone for weeks at a time because no one knew what the hell you were doing. But you did have to fix something. If you fix something, they would just leave you alone. All noise works this way. It's reference to ground, common mode signaling. Well, we don't do anything from conductor to ground anymore. We used to have ground start circuits back in the day, way back in the day. We don't have those anymore. Everything we do is a cross tip and ring. Engineers call that differential signaling. So if one of my electrical engineers were giving you this part of the class, he would say, well, folks, it's straightforward. You don't want any common mode noise to appear differentially. He would take a step back, a smile on his face, and figure that he did a great job. Well, then I would have to stand up as an interpreter and translate that into telephone talk. And I would say, what he means is you don't want noise to ground showing up across tip and ring. Right? Way all noise works on a cable pair. All right, I would encourage you, if you don't use that test to start, I want you to think of that dB number returned as a noise rejection number. The higher that noise, the more the higher that number, the more noise your cable pair will reject or deal with. There's an added benefit to that. The higher that number, the quieter your cable pair will be to the pairs surrounding it. Now, when DSL first came out, they had very strict limitations on the number of DSL pairs that could be in a binder group. Right? That didn't last very long. As soon as the phone company determined how much money they could make off DSL, right? Now your cables are just chock full of DSL signals. Well, MIT, one of the phone companies here in the United States, hired MIT to do a study. They took 25 pair cable and put 25 ADSL circuits on. They put one of those 25 ADSL circuits into trouble. The other 24 started taking errors. Right? You're in a high frequency radio environment, folks. Those cable pairs can hear one another now. There are so many crammed in the binder. Well, your best defense there is longitudinal balance. The higher the number, the more the cable pair will reject. The higher the number, the quieter the cable pair will be to the pair next to it. So very important. If you want to listen to this with your butt set, just connect from like the green ONX lead to the black ONX lead. Listen to what comes out of the butt set. You'll hear a real loud, annoying tone. Do the same thing with the red and black with your butt set, or red and green, excuse me. Same loud, annoying tone. So there's your noise signal split in half. Half of it goes from red to green, the other half black to green. Take your butt set then and just connect across the red and black and nothing else. And listen to it. It'll be stone cold silent. The reason for that is the butt set and the test set are very well balanced. The noise is self-canceled. Now all you got to do is take your hand, grab a hold of that green clip with the butt set still connected across to red and black. Grab a hold of that green clip in one hand and touch either the red or black clip with your other hand. You will begin to hear the noise. So there is common mode signal showing up differentially. Simple as simple can be, but one of the most important tests you can make on a cable pair. If you do have a sidekick, you know the sidekick can be do the stress test right into the dial tone, can it? So can the ONX. Right. The only difference between the sidekick and the ONX is the sidekick inverted the darn number. So the higher the number, the worse the pair. Right? That was a wonderful thing they did. They added a ton of confusion to the entire telephone industry by doing that. I've got a comparison chart between the sidekick and the ONX. If anybody's interested in that, send me an email. I'll email it to you. So any questions so far about these basic measurements? All right. I want to show you one quick thing with balance. I think we got enough time to do this. You're probably sitting there, and even if you have heard balance before, and even if you do use it on a regular basis, you might be saying to yourself, well, damn, this guy's making a big deal out of this test. I mean, I think it's all right and everything, but well, there are certain adaptations with this test that you can do that are very, very valuable. I'm going to show you one. Now, I want you to know somebody told me or taught me all this. I'm not smart enough to think all this stuff up, but I used to teach this with sporadically because when techs would hear it, they say, nah, I'm not doing that. It's too much running around. I ain't going to do that. But I had to do a class here. It's probably been, I don't know how many years ago. It's irrelevant. In Atlanta, Georgia, at a cable maintenance garage, I showed them this technique. I had to go back to the garage a couple years later, actually, and the same managers were there, and the manager said, "Boy, Jeff, I really got to thank you for what you showed us." Well, hell, I couldn't remember why I showed him. I can't remember my name after that. He said, "No, that thing with longitudinal balance." No, and then it popped into my mind. I said, "Hey, how's that working out for you?" He said, "Oh, it's working out great." Now, he had all of his guys start doing what I'm about to show you on chronic trouble, and he slashed his repeat report rate. I won't bore you with all the numbers. Tex and CenturyLink are doing this all across the country. I can give you names and contacts if you wanted to verify. So here it goes. Chronic case of trouble. Customer on the right, crossbox on the left, cable pair in the middle, of course. I want the cable pair open on both ends. I don't know about you when I'm testing the pair. I don't want the customer end to be tied down to a old protector that's attached to a green piece of IW going underneath the aluminum siding. Not if I'm testing the pair, right? I want that pair isolated from the house. Ideally, I want it floating free at the end. So, actual case of trouble I went out with one of his cable maintenance splicers. Repeat report for IPTV. We get to the crossbox, we do all the tests that we normally do, including longitudinal balance. We get a 72 for longitudinal balance. 60 or higher, right? 72 is wonderful. Now, thinking cap time. Since we didn't do the little bit with the butt set, you're just going to have to do it after this if you want to verify that I'm not lying to you. But when we run this longitudinal balance test, and if you hook up to it with your butt set, you're going to hear a loud tone, right? Now, what you're really listening to is an AC voltage. The only reason you and I hear it as a tone is because we hook a speaker to it, right? That's the only reason. But we can all relate to hearing something, right? But really, the signal is an AC voltage. So, no shorts, no grounds, no crosses. I do longitudinal balance. It looks wonderful. Here's where the adaptation starts. Before I leave the crossbox, I take the cable pair and short it, and then tie it to a ground lug in the crossbox. That's called short strap to ground in Atlanta, Georgia. I love the South. The next thing we do is we go out to the customer's location. If the cable pair is sound, the second measurement should come close, very close to the first measurement. Here's what we saw. The bottom dropped right out of the second measurement. Thinking cap time. When I applied longitudinal balance to a cable pair open-ended, I told you I was applying essentially an AC voltage. What do you think happens to an AC voltage when you short it and give it a path to ground? What do you think it turns into? It turns into an AC current. Now I'm pumping current down those two wires, and this result is telling me, hey, wait a minute, you've got a substantial difference in current flow one wire versus the other. Now I'm going to stop right here just for a second, because if you're anything at all like I was, all this current and voltage and all that stuff, it can be a little intimidating. In fact, electricity in general turns a lot of people off, right? It's invisible and it can kill you. Not charming things to want you to look into it. When I was more prideful, younger, now I don't care. I'm an old guy, but I used to say all the time, I wish I had Google. Because you type in basic electricity in Google in 0.3 of a second, you got 700,000 hits, right? If you go to some of those sites, they're spectacular. They're so well done, animated, all this stuff. I don't know if you've ever noticed that electricity is often compared to water systems. They'll say, like, the water pump is like voltage. It applies the pressure, right? The ability to do work. The water flowing in the pipes, that's sort of like current. Right? And then the pipes themselves are sort of like the resistors. Do I have a garden hose or do I have a fire hose? So if you want to think of this water analogy instead of current and voltage, all I'm saying is now I got two garden hoses laying there and I'm pumping water down. And the test result is saying, hey, there's something really messing up one of these garden hoses. But remember, we checked it from the crossbox. It was clean. It looked great. Now, techs usually jump to the conclusion, they'll say, it's a high open. No, it ain't. High opens are easy. You all got TDRs. If you don't know how to shoot a high open with a TDR, you better start. All right? High opens were terrible in my day because we didn't have TDRs. The type of trouble I'm talking about here is something called a series fault. What that means is that a Scotch lock at one splice, for whatever reason, has 11 more ohms in it than its sister Scotch lock on the other conductor. That's a series fault. That's much harder to find and identify than a high open. My water analogy would be the equivalent of me walking halfway down that garden hose and putting my big fat toe on one of the hoses and not on the other. What did we do? We put the TDR on it. What do they look like, these series fault things? They look like the most innocent little bump up you've ever seen. We both agreed about 350 feet away from us, we didn't like what we saw. We walked down there. Sure enough, the customer's cable pair was beamed through a terminal splice. Now, bean connector, guys probably know what that is. It's primarily used in Bell. It was an old white compression connector. They had a life expectancy of 25 years. So we cut that out, that terminal splice, twisted it up, put Scotch locks on it, walked back to the customer's house, did another longitudinal balance. The 40 had gone to 69. End of chronic, end of trouble. Now, these series faults, the reason they're problematic is they don't stay at 11 ohms. If they stayed at 11 ohms, you'd never know they were there, right? Because essentially, DSL works over barbed wire. I think we'll all agree. Remember the early days? Customer, you go to their house, kids playing on the computer, and the lady says, no, the computer's fine. It's the phone that's out. Huh? Work when it's dead shorted. I swear to God, they work over barbed wire. What they cannot stand is dynamic change. So if that 11 ohms starts to float up or down, the modems see that instantly and start taking errors. So as this goes up and down with movement and temperature, the modem's only going to take so many errors and boom, it's going to drop like a stone. Drop like a stone. All right. In the past, I've had older guys say, Jeff, I see what you're doing. I do it different, but I'm doing the same thing you're doing. I say, how you do it? They say, I do it with my own meter. So I short and ground the pair, like you said, and I just take my own meter. I see how many ohms I got on one conductor to ground. I compare how many ohms I got to the other conductor to ground. I'm doing the same thing you are. I say to them, no, you're not, for 3 reasons. Reason number 1, you can do this. There's nothing wrong with it. You'll read the resistance in the conductor, but you will also read the ground return path resistance. In most cases, that will drive your ohm meter into a 3-digit result. Now you have a range and resolution problem because the 3rd digit will start to roll up and down. We are looking for single-digit differences here. So you'll look at that and say, damn, is that trouble or is that just what, you know? That's reason number 1. Reason number 2, let's say everything is perfect. You do it with your own meter and by golly, you do see 11 ohms difference one side the other. Except the 11 ohms is distributed along the length of the pair. Meaning, I pick up a half an ohm at this splice. I pick up a full ohm at this splice. 3/4 of an ohm at this splice. You follow me? Good luck trying to find that with your ohm meter. And the third and final reason, what did we say power an ohm meter? a DC battery source. If you flow DC current down a cable pair that has a series fault in it, the DC current has a tendency to clean that up, temporarily, of course. Years ago, an analog carrier, they deliberately ran high levels of DC current on the carrier pairs. They called it sealing current to deal with series faults. When you use longitudinal balance, you are applying an AC signal, the same signal that the service uses. So go ahead and do it with the ohm meter, but you sure as heck are not doing the same thing. No. If you don't get anything out of this today, folks, remember this and give it a shot. When should I try it, Jeff? Try it when the second number drops, the bottom drops right out of it. Well, why should I wait that long? Because if you wait till you get one like I got up here, you'll find it. You'll have to be blind not to find it. You will find it. And then once you find it, you will prove to yourself that it works, right? I'll chase them if they get 6 dB different. But I've been doing it quite a bit. So, okay, that's our basic test. That's our technology discussion. Now we're going to go to the TDR. TDR stands for Time Domain Reflectometer, right? That's a pretty fancy word for radar or sonar. Hopefully you can see my PDF there. Theory of operation. TDRs are simple. I mean, I couldn't build one, but in the theory of operation, they're simple. They send a high frequency energy pulse down the cable pair at a known speed because you, the operator, tell it the speed, right? By selecting the gauge and fill type of the cable. The TDR's one most impressive thing is its ability to count time. It has a Rolex stopwatch built into it. So you send the energy pulse down the cable pair, starting TDR, it starts to count time, 1001, 1000. Oh, here comes it. Energy reflecting back. Now, the energy reflecting back is off of something called an impedance irregularity. $25 word for cable trouble. So I know how fast the signal's traveling. I got this supercharged stopwatch. I do a third grade time to distance equation. That's all and how they work. Any good TDR discussion should always start out with what are they good at and what can they just not do. Well, here, this list is not made to be all-encompassing, folks. It's just to capture the common things and whether the TDR is the preferred or non-preferred method of looking at those things. Low resistance faults across tip and ring. Yep, TDR pretty good at that. What type of short, though? A dead short, a solid short. If you're still using your sidekick, that needle better be whacking over to one side. Right? If you came up to me and said, Jeff, I got a 10,000 ohm short, can I use my TDR? I will say, hell no. So the shorts have to be dead. They have to be solid. Low resistance faults from tip or ring to ground. No, not really. All of us have stumbled across the ground with a TDR before. I have met some guys that swear they can find grounds. Well, I'm not going to argue with them, but a TDR has no ground reference. There's some tricks you can do to look for a ground, but it's beyond the scope of what we're going to talk about. Opens of all types, heavyweight champion of the world, double-sided, single-sided, high resistance opens, and series faults, all viewable by the TDR. Bridge tap, same thing. Only thing I know that show you the start of the tap, and if you're lucky, even show you the end. Aside from a high resistance open, TDR will not do a high resistance anything else. That's why all these meters have resistive fault locators built into them. And finally, load coil. Notice there's a check mark in both. I can sure see the first one, but I can't look through it. Why is that? Because the load coil blocks high frequency energy, doesn't it? Same reason you can't have a load coil on your DSL pair, because it's high frequency energy. All right. When you leave the world of the multimeter and go into the world of the TDR, you're leaving the objective and going to the subjective, meaning that you're going to interpret a picture. Three basic rules of interpretation: flat is good. The flatter the line, the more tip looks like rain. A dip down is a lowering of impedance, either caused by a short or the start of a bridge tap. A bump up, on the other hand, is an increase in impedance, either caused by an open, partial open, or a load coil. Everything else will be a combination of those three things, flat, up, and down. Like all good vendors, we show you a little sheet there, or little sample traces there, see on the screen. Kind of sounds like I'm making fun of them. I mean, they're good. But I'll tell you what, folks. Nothing looks like cable except cable. Now, guys and gals ask me, what, how do you do the TDR? How do you use it? I use it on everything. You're not going to hurt anything with it. I pointed at everything. It's fast. Why do you do that? I want to start building up the database in my head of what stuff looks like. I especially use it when I already know where the trouble's at. That's a great time if you're more of a novice to use the TDR. Use it constantly. You will build up that mental database. I'm at Mrs. Jones's house. I know she has a fax machine on that line. Shoot it with TDR. See what the fax machine looks like. All right? You guys do that for a few months, you'll surprise yourself on how good you'll get. All right, the ONX TDR. We touched the TDR icon. Now we've got a sort of a, well, we got a lot of modes here. But remember, this is just, we're going to do things nice and simple here. We're not going to just go wild with the modes. But this is a touch screen, right? On the touch screen, you have several different function areas. Now, what we do with the GUI, the interface, is we put a particular area in what the engineers call focus. That is defined by the purple border around a feature. See how I got that purple border around where it says quick range? That means that quick range is in focus. So if I use my right arrow button, I will start to increase the range. Well, you might say to yourself, well, hell, I want to get down there where that trace is. That's where I want to be. Well, you got to touch in that checkerboard area with your finger. See how the purple border goes around it? Now it's in focus. Same way with gain. Touch the area, purple border, it's in focus. Now, the HST has been around for a long time. In fact, there's over 120,000 HSTs in the field in different parts of the world. It's easily the most successful access test set that I think has ever been made. One legitimate criticism of the HST's TDR, and I will just have to agree, is there are a lot of options. There's a lot of settings. Some of the settings are mutually exclusive of other settings. So you turn a particular setting on, it shuts off another setting. Well, from an instructor standpoint, that's the worst thing in the world you could do, right? But the reason we did that is we try to incorporate all of our customer feedback, right? This particular company said, we'd really like to see you do this. And said, well, we'd really like to see you do that. Well, we tried a little bit too hard to put all that in. So in the ONX, a huge emphasis was placed on simplicity of operation. Now, we have different modes under soft key number 1. We've got a standard mode. We've got an in-home mode. We've got something called Smart Gain, and you folks may or may not have OneCheck. If you don't have OneCheck, don't sweat it. It's coming in the software release. All right. But I'm just talking about plain old standard mode right now. Now, the idea with standard mode, in fact, in any of the modes, was simple. Hook up to the cable pair you want to test, and start walking your way out the cable. Walking in terms of using the range. So right now I'm in a real short range. I start hitting that plus key, I'm going to start walking my way out the cable. You notice that each time I pressed the plus key, the gain and the pulse width will automatically change. Right? So I'm just walking my way, I'm hitting one button. Everything else is being done for me. Right? I walk my way out the cable until I see an event, until I see something that's not a flat line. So I see there's a significant dip down, and then after the dip down, there's a bump up. Now, if I would have followed good practice and put my voltmeter on here, I would know whether or not that cable pair was shorted or not shorted. If it was not shorted, then I would know that dip down is not a short. It's got to be something else. It's probably a bridge tap. Now, like I said, I'm not a prideful guy, so I'll show you how dumb I was. It took me about 2 weeks to realize down here in the checkerboard area, somewhat touching that checkerboard area, those footage markers across the bottom are extremely accurate. And they change as you walk your way out the cable. I didn't know that. I just kind of ignored them. Well, I'm lazy. I don't know about y'all. I'm old and I'm lazy. So what that means is I can look at those footage markers across the bottom and say, well, that first event's a little less than 1,000 feet. The second one's a little less than 2,000 feet. Just with a glance. Right? Because those distance markers are accurate. Well, of course, there's going to be times when you want to move the cursor. Well, you first got to put that area in focus. 2 ways to move it. You can touch the box where it says mark 0 feet on my screen. You can touch that with your index finger and drag it. Okay. See how the footage changed from 0 to 933 feet? Placing the cursor is another subjective thing. I like to place the cursor where the horizontal line leaves horizontal and goes vertical in either direction, up or down. Now, modern TDRs have all sorts of fancy things, like dual cursors. They got all kinds of wild stuff. You may be asking yourself, well, what the hell does that mark mean underneath the footage? It's our way of doing dual cursor. So I've got a pinpoint now on where I think that bridge tap is at 933 feet, but I've got another event out there, right? If I hit the word mark, it changes to a triangle with 0 feet. The triangle means delta. All I've done is driven a stake in the ground and hooked a tape measure to it. Now I'm going to drag that tape measure out to the second event. Right? And I screwed that up with my finger, I'm sorry. To love live demos. I hit mark. That places a stake in the ground. I drag my second cursor out to the second fault. Now I have the distance to the first, I have the distance to the second, and I have the distance between the two. All right? Now, some guys use this, most don't. Most get bored with it after the first few times I use it. So the way to shut it off is just touch that triangle area until it says mark again, and you will have shut it off. So that's how I move the cursor. Now you will find by using quick range that we do a really good job at controlling gain and pulse width. But some of you guys may have used TDRs a lot, and you don't like somebody telling you you can't use the gain. So those features are still changeable. You can click down here and gain it if you want. If you don't like my gain, you can use your gain. The trick to gain is only use as much gain as necessary to see your trouble. If you go wild with the gain button, you will make a perfectly good cable pair look terrible. All right. As far as the other modes, I'm going to skip over in-home. I'm going to show you a quick, and we'll discuss in-home at a different time, but now is not the time. And I'm basing this on value for you folks. On value for you folks. I'm not basing it on a marketing presentation. I want to hit the topics that are going to be the most valuable to you. Smart gain. Now, smart gain looks a little bit different than our standard TDR in that we don't have that launch pulse, that bump all the way over to the left. The idea with smart gain is to have a zero dead zone TDR. Now, I don't know what you know or what you don't know about TDRs, but TDRs, time domain reflectometers, always deal with something called a blind spot or a dead zone. Now, there's a real simple explanation for that. I'll draw it up here for you quick. When you turn the TDR on, you turn a transmitter on, but at the same time, you turn a very sensitive receiver on. Now, there's two terms that TDR operators like to throw around, especially when they're around people that are non-TDR experts. Those two terms are pulse width and pulse height. Huh? Pulse width is nothing more than how long the transmitter is in the on position. So in my training classes, you remember that commercial a few years ago? It was Office Depot, I think. They had that big red button. It was called the easy button. They hit that button, everything got fixed. Think of that button as being the transmitter button. So if you tap that with your thumb, that's the amount of time the transmitter's on. If you just tap it quick. One of the cardinal rules of using a TDR is to start in short range and work your way out. That's a cardinal rule. If you don't follow that rule, I will guarantee you will get bit in the butt sooner or later. The reason for that is the amount of time this guy is transmitting. For the same amount of time, this guy is going, I don't know what the heck is going on. I am getting flooded by this giant signal. I'm super sensitive, and something is just a bullhorn screaming in my ear. Time is distance in the world of the TDR. So in short range, I'm just tapping that with my thumb real quick. So the receiver's going, hey, whoa, oh, and then it calms down again, right? Now, a novice TDR user will say, you know, I don't care what that guy from Michigan said. The trouble's out here. I'm skipping ranges because I know where the trouble's at. And he goes to medium range, right? Well, what has he done with the transmitter? He's held his thumb down longer. That means to the receiver's going, I don't know what the hell's going on. Longer. And if this particular cable pair has a case of trouble back here, you just blew right past it. Huh? So for however long your thumb's on the red button, that's pulse width. Pulse height, what's the volume, Kenneth? Right? Think of it as a volume knob. That's all gain is. Pulse height, amplitude, volume. We could use much simpler words to describe this stuff now, couldn't we? So Smart Gain TDR has zero dead zone. It doesn't have a bump. On the standard one you saw, you had this bump right on the screen, and then it went flat. Well, Smart Gain goes flat from the get-go. There's an electrical reason we do that. It's unimportant. The important thing is that it doesn't have its dead zone. So you can get very, very close to trouble with Smart Gain and still see it. Now it operates just like the other one in that you walk your way out the cable. There is a difference in setting. And that reminds me, I didn't show you where the cable selection was on standard. I'll come back to that in a second. You see it clean down at the bottom. There says fine tune. What that fine tune button wants you to do is select the dominant gauge of cable you think you're working on. You notice if you hit that plus button, it goes up a half a gauge at a time. You might be saying, what the hell's up with that? Well, it's because you guys are always saying you're on mixed gauge cable, right? So this fine tune doesn't go any higher than 26.5, no lower than 21, I think. So if you're on 19 gauge, just crank it down to 21. You're going to be fine. For your high-end TDR users, guys that have used TDRs for a long time, think of this as a filter. It is. It's a filter. Your pan and zoom are pretty obvious. If you look down in the pan and zoom area, zoom will let you zoom in on wherever you have the cursor placed. Pan lets you look left and right on the cable pair at the same magnification. In other words, it's not zooming. So if you look down here, it's maybe impossible for you to see over the internet. I don't know. But you can see the big open up, right? But you don't see it on the screen because all that's visible is this little white portion here. It's really, let me range out here to show that to you a little better. As I range out, see how the white portion of pan and zoom starts to get wider? Now, the thing that shows terribly is this simulation for using SmartGain and all the equipment I'm pumping through to get it up on the internet. So that line starts to disappear. Here's my bridge tap. It's the same trace we were looking at before. So if I walk out there, there's my open end. So open a little less than 2,000, bridge tap start a little less than 1,000. I think you guys and gals will find yourself using it just like I do. So I'm going to jump back to standard quick. I know this is a no-no for an instructor, but I did not point out where to change the speed. That's under options and cable type. The speed of the signal is determined by you telling the TDR the fill and the gauge of the cable. That's called velocity of propagation or velocity factor. Fancy word for speed. I tell everybody I leave mine on AirCore 24 99.9% of the time. I made the mistake of telling a training class live here in Michigan, 30 miles from my house, 25 guys. I made the comment I just made. You would have thought I slapped the one technician's mother. He said, well, I'll tell you what, I change mine every time I use it. I was just kind of taken aback. Well, that's cool. That's great, man. If you want that extra foot of accuracy, well, that's a great habit. It kind of freaked me out a little bit. But I'll be honest, I just leave it on AirCore 24. It gets pretty damn close. Let's see. You're probably interested. We still got a little time. Underneath options, we have this thing called stress. Now, we also have a landscape mode. I'm not gonna, these are just viewing things. The landscape, you can turn it, if you don't have landscape, don't panic, you will get it. All it does is let you lay your ONX on the side. That's all it does, okay? Pretty cool, but that's all it does. The feature of stress is kind of neat. If you touch stress, what happens with the TDR is it's shut off. And remember that 120 volt ohm meter I talked about for shorts and grounds? We shut the TDR off, we whack the line with 120 volts, and we turn the TDR right back on again. All right? The thought being is that if something happens, that whack of 120 volts, I'm going to capture it, the difference between applying the 120 and not applying the 120. So let me do that again. Stress, see the triangle, I'm whacking it. I'm going to display any difference between the two traces in a different color. See how I've got the blue there now. Now this is done to aid you folks in doing high opens. Like I said, in my day, high opens were a bugger. One of the ways you could get them to act up is go out to the customer's house, ring the phone back. They go static. You could chase them for a while. So you may be saying, well, why in the hell do we just ring the phone back with the TDR? You can't. The TDR is what's called a UL listed device. Doesn't mean anything to you. It's a huge deal to us. underwriter's laboratory. That means I've passed all these government standards. I'm handing you a piece of equipment that's going to do its best to keep you safe. So if you hook this up, ring the phone back, the ONX is saying, hey, I don't know if that's something that's going to kill this guy or if he's just ringing somebody's phone back. So it shuts everything down. The only thing that's left operational is the voltmeter. So our engineers thought this whole idea of whacking it with voltage was a pretty good idea. So we figured out a way around it, and that was to use stress. So the sequence, touch stress, I ram 120 volts on it, shut the TDR off first, hit it with the voltage, turn the TDR right back on again. This is happening really fast. Now, one thing I didn't tell you about our resistance meter, because if you're listening hard, you may be saying to yourself, wait a minute, I think Jeff's contradicting. Because didn't he say that DC current, that DC voltage, has a way to seal things up? Well, our ohm meter is not just an ohm meter, not an ohm meter. We apply the DC all right, but we apply it in a dual polarity sense. So we give you a shot of one polarity, we flip polarity, give you a shot of another. So you will not seal stuff up with our ohm meter. So that's peak stress. Any specific questions you guys and gals may have about the TDR? Now, it'd be a great time to ask, folks, if you do, because we're fixing to switch to DSL. Okay, I'm assuming you're cool. Now, the TDR will do a lot of other things. Like I told John, our sales guy, you know, we do this stuff on a regular basis. We'll customize it for you. We'll do short half-hour things. You want to call me on the phone, I'll tell you how something works if you've come across it. So I just want to give you an option to ask questions now. So I'm going to leave TDR if you don't have any questions. I would probably, I would use either standard mode or smart gain. Those would be the two that I recommend. Now, if you don't have OneCheck, when OneCheck comes out, it is going to be pretty cool. I'll show it to you here. But I hate showing you stuff that you don't have. What OneCheck does is latch on to whatever it sees trouble-wise. So you can move from pair to pair, and it will automatically update itself. You don't have to touch anything. So I just moved to a second cable pair that's shorted. Now it might go wild and then it settles down. Let's see how the open went from open to a short. So as events appear, it latches onto them. So I just stuck that bridge tap in. See how it latched onto it? This is all automatic. It's all real time, all automatic. Now you're probably sitting there thinking, man, that's really cool. I can't wait to. It is really cool. It is really cool. But, you know, please spend a little time trying to get to know the instrument, get to know how the TDR works. I want you guys and gals to think of this as icing on the cake, right? Icing on the cake. All right, that's coming. If you don't have it, it's coming. So DSL, have you guys and gals been given any DSL training, or has it all been on the job stuff? That is an actual real live question. So
On the job.
On the job. Thank you for that. So we'll approach this the same way we approach the other training classes. We're going to start with ADSL. If you understand ADSL, you will understand all the technologies with the exception of G.fast, which I don't know if you guys are playing around with yet or not. So you get ADSL 1, you're going to get all the way through VDSL, if you understand this one. I start off my live training classes by asking techs, what does ADSL stand for? 1 out of 100 can give me the correct definition. Most say asynchronous digital subscriber line. It's not. It's asymmetrical digital subscriber line. What does asymmetrical mean? I had one tech, I kind of liked the guy. He's a little bit of a smart aleck like me, you know. He said non-symmetrical. I said, yeah, you're right. If you hold your two hands up, unless you've been in a terrible accident, your mama did a pretty good job. Your hands are the same size. They're said to be symmetrical. Now, if you got one of the world's largest telephone guys in there, he's 6'8", weighs 350 pounds. He holds his hand up. Chances are his hand going to be a hell of a lot bigger than your hand. Therefore, that would be an asymmetrical relationship. I told you earlier that all this DSL stuff, when it's on the cable pair, is an AC tone or voltage, however you want to think about it. Tone is probably easier for you to think of. Huh? So I have a group of frequencies that operate ADSL. Those frequencies start around 20,000 cycles per second and go all the way up to 1.1 million cycles per second. Right? So a whole radio bandwidth of frequencies for ADSL one line. Now, ADSL was designed originally to surf the internet. Now, technicians have a hard time remembering this. It's not that they don't understand it. They have a hard time remembering it. DSL is a transmit and receive environment. All I mean by that is you got information coming from the customer going to the internet, and then you've got information from the internet coming to the customer. That's all I mean. Well, originally it was designed to surf the web. Well, what goes upstream when you're surfing the web? A mouse click? You don't need very many of these frequencies designated to the upstream because you're just clicking with the mouse. The person that described DSL to me used this series of boxes like I'm going to use with you. This guy was an absolute genius in my mind because he could get relatively tough topics through a thick-headed guy like me. So these are frequencies, they're groups of frequencies, but we're going to let them designated by boxes. Now, what the heck did you click on while you're surfing the internet? Maybe last night's prize fight? So you might have a ton of information coming downstream to you, right? So ADSL, much bigger box for the downstream information than the upstream information. Now, these aren't boxes, these are frequencies. I don't want the frequencies from the upstream to mix in with the frequencies of the downstream. Therefore, I put a little dead air between them. See that right there? There's nothing there. It's called a guard band. Inside the boxes, there's a series of little boxes. In my day, they were called bins. The hip new terminology is tones. Don't ask me why. I'm trying to draw each one a 1/4 inch wide. I'm failing miserably. Each one is a certain width wide. Now, if you want to think inches, that's fine. But it's a certain amount of frequencies wide. There is a total of little boxes in both the upstream and downstream of 256. So there's 256 of those little 1/4 inch wide boxes. It's in the boxes that the bits of data are carried. There's a certain number of bits per box. It's kind of irrelevant. Each one of the little boxes in real world is roughly 4,000 cycles wide. Now, we can talk inches and 1/4 inches and all that stuff, but remember, we're really divvying up frequencies here. But it's simple as hell. Each one of the boxes are 4,000 cycles wide, right? Now, we're going to find out who's old, if anyone. Who remembers the last dial-up modem you worked on before we got ISDN and DSL? What was that last dial-up modem? What was the speed? Everybody had to have one. Can anybody remember? Oh, must have a bunch of young guys. Come on. The 56 kilobit modem.
64K.
56K. Yeah. 56K. Right on, brother. 56 kilobit. Everybody and their brother had to have one of them modems. 56 kilobit modem relied on you providing a frequency bandwidth of 4,000 cycles on your cable pair. If you provided 4,000 cycles, you would get, theoretically, the 56 kilobit. Okay? ADSL is like having 256 56 kilobit modems all running at the same time. So each one of those quarter-inch wide boxes sometimes are called little modems, mini modems, whatever you want to call it. Each one operates like an individual 56 kilobit modem. And there's 256 of them. You do the math. Now you sit here and you may say to yourself, well, wait a minute now, Jeff, this is all fine and well, but we don't do ADSL, we do ADSL 2+. Well, guess what they did? Instead of stopping at 1.1, they go out to 2.2 million cycles. They doubled it. Instead of having 256 56 kilobit modems, they got 512. Huh? Doubled it. VDSL, the Mac Daddy. A very common profile goes out to 8 million cycles per second. And I always get this one wrong, but I'm close. For a total of 1,974 individual 56 kilobit modems, all running at the same time. So if you understand ADSL, you understand them all. There's just more boxes and more frequencies. Okay, in a canned sense, in a sense of what, I guess I'm not a big fan of doing these really short classes, but what do I really need to know? Well, this is called discrete multitone. And all I want you to know is that if you understood that first example, all the rest of it's the same. There's just more frequency, right? Higher frequency, wider bandwidth of frequency. What comes along with that? Shorter distance. Shorter distance. If you remember one sentence from this training a year from now, if I were to meet you, I'd walk around and puff my chest out like a rooster. That sentence is, the higher the frequency, the more the loss over the same distance. Higher frequency, the more the loss over the same distance. Well, you guys know that, right? ADSL 1 worked farther than VDSL, right? Each new VDSL they come out with, it's faster, but you notice it gets shorter? What you think they bond them for? Higher the frequency, the more the loss, same given distance. I'm going to show you a couple quick things on DSL sync stats, and then we're going to wrap this puppy up. So when you sync up, of course, you look at the max and actual rate, right? That's on the opening screen there. So you got actual rate, you got max, you got capacity. Now, capacity is a calculation. It is not a measurement. I don't know what CenturyLink's position is on capacity right now. I will tell you that the large portion of North America has changed. They say 100% capacity. Now, back when we started doing this, you couldn't 100%, that's bad. DSL was designed to run at 100% capacity, provided there were no errors. That was the big thing. Okay. Margin. Those are probably just two numbers to you, right? You got an upstream margin and downstream, and CenturyLink says they have to be above a certain number of dB, right? Well, I'm going to explain noise margin the way I do it and see if it makes sense. The magic behind the DSL line, in my opinion, is the transceivers in the DSLAM and the modem. Now, a transceiver is just a fancy word for a combination transmitter receiver. They are extremely sensitive, right? They're capable of picking up enough data for you to watch high definition TV from signals that in my day, we wouldn't even consider them signals. They were so weak. Huh? Well, I'm a big believer in logic. And if something doesn't make sense in a logical fashion, eh, you got two things. You got two ways to learn, right? It either logically makes sense to you or you're forced to memorize. I don't know which one you like. I know which one I like. So if the signals are that weak, what does that mean? Doesn't take a lot of noise to interfere with them then. Logical. If the transceivers are that sensitive, what does that mean? That means that any cable pair you do an install on is going to have a measurable level of noise. You've got Superman's ears listening to the damn cable pair. So let's measure the noise. From the bottom of the easel up to here is our noise level. Now we're going to apply a DSL signal level. Okay? And it's going to ride atop that noise. Okay? Let's measure it. Same spot. Bottom of the easel up to the noise level, or up to the DSL signal level. Okay? So I got two measurements there. Noise margin is nothing more than the distance between this and this. So instead of saying, well, maybe 7 inches, it's so many dB. Right? Now, we don't have a lot of time to get into the noise stuff, the noise capability of this test set. But technicians are always interested in, okay, I got you. How much noise is too much noise? I can't tell you that. Because DSL is what's called a rate reach technology, meaning that, did you notice when I drew the DSL line, I drew it going down and to the right? DSL signals go down and to the right, fellas. In other words, the minute they leave the VRAD or the DSLAM, they are constantly losing signal strength. Down and to the right. Noise is dynamic. So let's say I take a great big hit of noise on a real short DSL line. I've got enough margin to where my noise doesn't get into my signal. All right? I take the same exact volume of noise and I put it out here on a longer DSL line, and I got an issue because the noise is into my signal. All right? This is conceptual stuff. It's very, very good for you to know. Right? So this whole thing is called rate reach. So we'll go to the ONX, show you I'm sunk up here. So on the ONX itself, actual rate, max rate, I have no DSLAM control, so I'm running everything wide open here. Here's my two margins, right? Satin and Latin, think of Latin. Latin is line attenuation, the distance between the DSLAM and the modem. It is a useful thing in some instances. What's worse, a CRC or FEC? Anybody? CRC. CRC is 100 times worse than FEC. FEC stands for forward error correction. Essentially, in layman's terms, and that's all I understand it, I'm the DSLAM, you're the modem. We sent something, I sent something to you. We recognized it was screwed up, and we fixed it along the way. But we still got to count it. So we say 1 FEC. Right? A CRC is cyclic redundancy check. It's often called code violation. It's 100 times worse than the FEC because it means between you and me, we flat lost it. It was no recovering it. We lost it. That's another real important thing to get in your head if you're doing installs for CenturyLink. Because guys and gals will get on an error screen. No one's ever told them anything, right? But they're looking at that damn error screen and they know they don't want errors. Well, they got this FEC thing coming. So if you're anything like me, you done the install, you got your test set sunk up on the side of the house, you're just going to let it sit there and sink for a while and pick up your stuff, right? And then you come back and look at it, and you see that you got some of these speck things going on. And it's like one every half a minute or so, and then it might go a minute and not have any. Well, you're looking at your watch, it's 4:20, kid's got a ball game. I'm out of here. Boom, you leave. Oh, you never hear anything back. So a couple months later, you got another one. Right? You're doing the same thing. You're picking up your stuff. The thing's hanging on the side of the house. You're looking at it. This time you got CRCs, but they're acting the same way the FECs did. They're just one, and then another one. And you're thinking to yourself, because no one ever told you the difference. Well, I walked away from that other one, never got a call. I'm walking away from this one. You will be back on this one, right? Or somebody will be back. So CRCs, real live, bad stuff. We lost it. You've got a variety of different things to look at under this modem, the DSL settings. I'm going to let you kind of play with that. I'm going to hit the main thing. DSL graphs, soft key number 2 there. DSL graphs will show you a picture of the boxes that I had drawn on the screen freehand. Remember when we were describing the upstream box and the downstream box? This is showing you the boxes, downstream 1, upstream 1, downstream 2, and how full these boxes are with information. Okay? How full they are. Any place you see white, that means that that area of the box is not carrying any information or very little information. This is a visual representation of how your data is distributed across all those boxes I was talking about. Higher the frequency, the more the loss for the same given distance. If that sinks into your head, you will see that appear over and over and over and over again. Because remember, from left to right, I'm going higher in frequency, right? Well, let's take a look at U2 here. I'm kind of stair-stepping down, which is a normal thing. The longer the line gets, the more it'll look like a set of stairs going down. But here at U2, I've got a chunk where I'm not carrying anything. There's nothing there. But I go to the higher frequency and I've got something. That means whatever I lost here in U2 is not due to distance. It's due to something else. Okay? Now, I told each class I've done, this sounds worse, so I'm going to say it, but then let me explain it. I don't know if I really want to tell you any more about these boxes. And here's what I'd like you to do. I would like you to try to make an effort to look at this box picture, bits per tone it's called. Each time you sync up, I want you to look at the box. Look at the box. I will guarantee you, because there is something that you guys and gals are experts at, and you don't give yourself any credit for it. I never gave myself any credit for it. And when it dawned on me, I kind of rolled my eyes and I said, yeah, I guess so. But it's really important. You're experts in pattern recognition. You're doing the same darn thing over and over again, all at different houses, different customers, different lengths. Your ability to pick up on patterns and trends is phenomenal. If I told you nothing about these boxes other than to just look at them, I bet you in 2 months you'd come back and you'd say, well, you know what, Jeff? I noticed when I got a big chunk of that D2 box missing, I know I got a bridge tap on the line. That's the stuff that you would start to pick up. Now, I can talk about frequency and all the physics and all that stuff until you guys' blood shoot out of your eyes, right? Keep it simple. Higher the frequency, the more the loss for the same distance. Now, there are several selections across here. The basic one, the one I want you to look at, bits per tone, BPT. Another cool one to look at, we're going to skip this one just for time. We're going to go to QLN. That stands for quiet line noise. Now, the reason there's two of these, there's trace 1 and trace 2, is for bonded service. Now, the guys that developed the GUI, they envisioned, you putting, I'm going to overlay signal noise on top of bits per tone. I'm going to do, and I find it all really confusing. So when I move it, I like to move both of them at the same time. But I'm going to move, just for example, I'm going to take trace 1 and move him over to quiet line. Wherever quiet line noise is high, bits per tone will be low. Wherever quiet line noise is low, bits per tone will be high. Huh? It's the noise that is robbing you of the box's ability to carry information. All right? So that's kind of a cool one. Now, if I'm starting to get to the area where, hey, Jeff, you're losing me with all this stuff, just go back to bits per tone, the boxes. Look at the boxes. All right? A good one is going to look like a set of stairs. Why? Higher the frequency, the more the loss for the same distance. So you're going to have a box that kind of goes out and it's going to start stair-stepping its way down. And you may get out and you run completely out of, there's nothing there. It just stair-steps its way down. A bad one is going to look anything that doesn't follow the rule of physics. So if my boxes go boom and then come back up and start stair-stepping their way down, what have I done? I've just broken that rule. The higher the frequency, the more the loss for the same distance. So this big chunk missing here is not due to length. It's due to something else. 9 times out of 10, that's a bridge tap. Bridge tap robs you of bandwidth by reflecting. It bounces. The bridge tap, the AC signal goes down any place there's cable for it to go, right? So it goes down the bridge tap as well as the main leg. Well, this high frequency AC does not like to end abruptly. If you do not terminate it into a modem, what it does is it bounces back just like a TDR. Well, when that information from the bridge leg bounces back into the main leg, it has a nulling effect on the data. So it takes a big bite out of one of those boxes. All right, fellas, we're at the red line, rev limiter anyhow. Any questions? I know this was kind of a condensed deal. I asked the previous group for feedback. We really never heard anything, so we kept with our same mode of operation here. Idea again was to give you a little taste of the manual stuff, to particularly introduce the concept of balance to you, show you how to run the TDR, and give you a blip about DSL and not try to kill you in 2 hours. So that was our goal. So maybe one of you say something so I know that you're still alive. That would be great, but I'm kidding. So questions? Don't be afraid to go to your manager. Give us feedback if you don't like something. If you like something, that'd be great too. As I said earlier, these sessions don't cost CenturyLink or you anything other than your time out of the load, which is, I guess, pretty expensive. But we do them for free. You got my contact information. You want to call me, I'll help you any way I can. So
I got one question. If this was recorded, could you send this out as well?
Yeah, I will send it to our sales guy, and he will distribute it
Okay.
to the customers. Yep, I'll be glad to do that
All right.
for
Thank
you.
you.
You're welcome.
Appreciate it.
Okay, folks, going once, going twice. Last thing I got, as always, is to thank you for your time. You guys have been very polite. I hope it was worth your time. Man, if it wasn't, then I failed miserably. But it's been a pleasure presenting to you. I hope you got something out of it. Work safe, eh? And have a great day.